Hello everyone, Tracy here, the humorous tutor. In this video, we'll be breaking down some bone marking terminology. It's funny because breaking, like brachium, which is the arm. Anyway, let's move on. If you've not already left after that, let's be honest, horrible pun, let's begin by having a look at the types of bones. To understand the types of bones in our skeleton, here we've got a diagram of a full skeleton, and largely everything that we can see can be categorized into either long, short, flat, irregular, or sesamoid bones. The first category of bone is the long bone. These bones are much longer than they are wide, and this can largely be attributed to the length of the shaft. This is what most people picture when we say bone. Examples of these can be found in the limbs, such as the humerus in the arm and the femur in the upper leg. Next up are the short bones, and these are roughly equal in length and width, giving them kind of a cube-like appearance. Examples of these are the carpals in the wrist and the tarsals in the ankles. Next up are the flat bones. As the name suggests, these are thin and broad in appearance. Tying structure to function, flat bones typically provide a protective housing for internal organs. Examples of flat bones include the sternum and the ribs, making up the thoracic cage, protecting our heart and our lungs. Irregular bones are not regular. There's no real defined description as to how to describe irregular bones. As such, funky-shaped bones have been thrown into their own category. Examples of irregular bones include those within the skull or those in the pelvis. The last little category being the sesamoid bones. Sesamoid being derived from the Arabic word for sesame seed, tell us the shape that we kind of expect the bone to resemble. Sesamoid bones are largely found in joints, and our most notable example being the patella bone in the knee joint. Now let's have a look at some bone markings. First up, the head of a bone. The head typically refers to the rounded proximal end of a long bone. The opposite end of the long bone, or the distal end, is typically called the base. For example, the head of the humerus. Condyles are smooth, rounded projections on the end of a bone. Typically, they help to form articulations, or joints, for movement. An example of this would be the specialized condyles on the distal end of the humerus, the trochlea, and the capitulum. Processes are projections or sharp outgrowths in bone. These are very useful attachment points for other organs in the body. Examples of these include the transverse processes on our spinal column. Tuberosities are obvious rough surfaces on the bone. Generally speaking, these rough surfaces are due to mechanical stress placed on the bone, and as a result, the bone tends to remodel and grow in response to this stress to then form this notable tuberosity. For example, we sit down on our ischial tuberosities, on the bottom of our pelvis. Next up are the epicondyles. Just breaking down the lingo here a little bit. Epi meaning upon or on top of, and condyles referring to condyles that we had talked about earlier. Therefore, epicondyles are the small projections on top of or above condyles, and these often serve as attachment points for muscles or ligaments. So for example, there'll be a lateral and a medial epicondyle, each above the capitulum and the trochlea, respectively, on the humerus. Tubercles are small, rounded projections, also for muscle or ligament attachment. I don't know if you're sensing any trends here regarding muscle or ligament attachment. Tubercles and tuberosities I kind of find easy to confuse as they both start with TUB, tub. I kind of remember tuberosities, so I sit on the tuberosity, so because I'm sitting on it, there's a lot of mechanical stress, and so tuberosities must be the rough surface in response to that stress it's taking on, whereas the tubercles will then be the rounded projections for the usual muscle ligament organ attachment. Canals are passageways within bones. For example, the optic canals allow passage of the optic nerves into the back of the brain. Foramens are probably the easiest to describe. They are literally a hole in the bone. Towards the pelvis, I've just tried to circle in the obturator foramen, through which nerves and blood vessels pass through. A fossa is a shallow depression in a bone in such a way that it forms kind of a basin. A big example is the iliac fossa, here that I've circled on the pelvis. The two iliac fossas on either side form the basin-shaped structure of the pelvis. In terms of bone markings, spine doesn't describe our spinal column at all. Our spinal column is composed of vertebrae. Spines are actually sharp processes within bone. And what I've circled here are the ischial spines, which are, you can see through the obturator foramen, is the sharp process on the back and the bottom of the pelvis. So here are some examples of bone markings. What we've gone through here is by no means an extensive list of these bone markings, but I did pick the most common ones that are very likely to crop up in your anatomy studies. I think it's a great idea to get a great understanding of this early. Well, thank you for watching. I hope that you've learned something, even if it's just that I'm super lame. Did I do this whole video on bone markings just so I could talk about the humerus as my next video? Maybe. Maybe I did. See you next time.